In software testing and quality assurance, we are talking about the system test categories. What all we do in system test. And we'll see the taxonomy of system test, the basic test, the functionality test, the robustness test, interoperability test, the performance test, the scalability test, the stress test, the load and stability test, and regression test, documentation test, regulatory test, that is the software safety and safety assurance. So these are the type of test as we just saw. We'll be discussing all of these from basic to regulatory. These are the types of system test that we do. And the basic test, it provides an evidence that the system can be installed, configured, and be brought to an operational site. The functionality test would provide comprehensive testing over the full range of requirements within the capabilities of the system. The robustness test will determine how well the system would recover from certain input errors and various other failure situations. The interoperability test, it determines whether the system can interoperate with some other third-party products. The performance test will measure the performance characteristics, and these performance characteristics are throughput and response time under various conditions. Scalability test. This determines the scaling or expanding limits of the system in terms of the scaling, the geographic scaling, and the resource scaling. Then the stress test. Stress test put a system under stress in order to determine the limitation of a system. That is, when it fails, to determine the manner in which it fails, a failure will occur, how graceful it is, how bad it is. Load and stability. This test provides the evidence that the systems remain stable for a long period of time under full load. Reliability test. It measures the ability of the system to keep operating, that is, available for operation for a long time without developing the failures. Then the regression test. Regression test determines that the system remains stable as it cycles through the integration of other systems. That is, integrating other subsystems may not create any other errors, and through maintenance tasks also. The documentation test will ensure that the system user guides and other documents, supporting documents, are accurate and they are usable. So basic test. Let us start with the basic test. So what are the basic tests? First is the boot. The system, when it starts, how does it work? Then the upgrade and downgrade. The LEDs and the diagnostic and the CLI, that is command line interface. Boot means the boot tests are designed to verify that the system can boot up its software image or say build from the supported boot options. The upgrade and downgrade in basic test means the upgrade and downgrade test, these are designed to verify the system software can be upgraded or it can be downgraded, that is rolled back in a graceful manner. Then comes the LED, that is light emitting diode test. These are designed to verify that the system LED status indicators functioning as desired. Then comes the diagnostic. Diagnostic tests are designed to verify that the hardware components or the modules of the system are functioning as desired. That is power on self or post test, Ethernet loopback test, bit error test, and then comes the command line interface, that is the CLI test. These are designed to verify that the system can be configured. Then comes the functionality test. In functionality test, we'll see the communication system, the module, the logging and tracing, the element management system, the management information base, the GUI is a graphical user interface, the security and the feature. These are all the types of functionality test we're going to do. In the functionality test, we have communication system test. What is communication system test? These are designed to verify the implementation of the communication system as specified in the customer requirement specification. So 4 types of communication systems are recommended: basis interconnection tests, capability test, behavior test, and system resolution tests. Then the module test. Module tests, these are designed to verify that all the modules function individually as desired within the system. The idea or the aim here is to ensure that individual modules function correctly within the whole system. For instance, say an internet router contains modules such as line cards, the system controller, the power supply, and fan tray. So tests are designed to verify each of these functionalities. Then comes the logging and tracing test. Logging and tracing tests, these are designed to verify the configurations and operation of logging and tracing. So this also includes the verification of, say, flight data recorder non-volatile flash memory logs when the system would crash. EMS test, Element Management System test. EMS test verifies the main functionality, which are to manage, monitor, and upgrade the communication system network elements. So it includes both EMS client and the server's functionality. And I'm not going into the detail. The MIB or Management Information Base, these are MIB tests. MIB tests are designed to verify the standard MIBs or Management Information Base and Enterprise MIBs specific to that system. Again, we'll not go to the detail of this. The functionality test, that is the GUI test, Graphical User Interface test. These are the tests which are designed to see the look and feel, that is look and feel the interface to the users of the application system. The tests are designed to verify different components such as icons, the menu bars, the diagonal boxes, the scroll bars, list boxes, radio buttons, etc. The GUI can be utilized to test the functionality behind the interface, such as accurate response to the database queries, and test the usefulness of online help, error messages, tutorials, and user manuals. The usability characteristics of GUI is tested, which include the accessibility, responsiveness, efficiency, comprehensibility. What is accessibility? Can user enter, navigate, and exit with relative ease? Responsiveness means can user do what they want and when they want in a way that is clear? Efficiency, can user do what they want with minimum number of steps and time? Then comprehensibility. Do user understand the product structure with a minimum amount of effort? So usability characteristics correspond to accessibility, responsiveness, efficiency, and comprehensibility. Then comes the security test. These are designed to verify the system meets the security requirements. Confidentiality, integrity, and availability. CIA. Confidentiality, integrity, and availability. Confidentiality means this is the requirement that data and processes be protected from some unauthorized disclosure. Integrity means it is a requirement that the data and process be protected from unauthorized modification. Then the availability, that is the third part, which is the requirement that the data and processes be protected from the denial of service to authorized servers or the users. So these are the CIA security tests. Security test scenarios should include the negative scenarios also, such as misuse or abuse of the software system. Then comes the system test, which is a useful type of security test, which we may include the verification that only authorized access to the system are permitted. Verify the robustness or the correctness of both encryption and decryption algorithm for the system where data messages are encoded, and verify the illegal reading of files to which the perpetrator or the infiltrator is not authorized or it is not he or she is not allowed. We need to ensure that the virus checkers prevent or curtail entry of viruses into the system, and also to ensure that the system is available to the authorized user when a zero-day attack actually occurs, and try to identify any vulnerability, that is the backdoor in the system usually left open by the software developers. Feature test. These tests are designed to verify any additional functionality which are defined in requirement specification but which are not covered in the functional category which are discussed. For example, data conversion testing, cross-functionality testing. Robustness test. Robustness means how much a sensitive information is to erroneous input and changes in operational environment. So tests in this category, they are designed to verify how gracefully the system behaves in any error situation and in any change or modified operational environment. So these are the type of robustness tests we apply: boundary value, power cycling, online insertion and removal, high availability and degraded mode. Boundary value. What is this? These tests are designed to cover boundary conditions, special values, and system defaults. The test will include providing invalid input data to the system and observing how the system is going to react to this data which is not valid. Power cycling. Power cycling tests are executed to ensure that when there is a power glitch in a deployment environment, the system can recover from the glitch to be back in normal operation after the power is restored. Power cycling. Online insertion and removal. This OIR, these are the tests designed to ensure that online insertion and removal of modules incurring during both idle and heavy load operations are gracefully handled and recovered. That means if the load is high, some functionality which we have thought may not be available. Okay, we may just try to avoid them or ignore them for some time, and when the load is less, then this functionality user can avail. Then comes the high availability. The concept of high availability is also known as the fault tolerance. High availability tests are designed to verify the redundancy of individual modules, including the software that control these modules. The idea is to verify that the system gracefully and quickly recovers come back from the hardware or software failure without even adversely affecting or impacting the operation of the system. High availability is realized by means of proactive methods to maximize the service uptime and also to minimize the downtime. Then comes the degraded node. Degraded node, also known as the failure containment. This test verifies the operation of a system after a portion of the system becomes non-operational. So if one node is not working, others should not be so much dependent that they also stop working. So it is useful test for all mission critical applications. Interoperability test. These are the tests designed to verify the ability of the system to interoperate with the third-party products. We'll try to briefly cover this. To reconfigure activities during interoperability test is known as configuration testing. Another kind of interoperability test is what we call as backward compatibility test. So compatibility test verify that the system works the same way across different platform, operating system, database management system, etc. Backward compatibility test would verify that the current software build flawlessly works in also the older version of the platforms. Then comes the performance test. These are the tests which are designed to determine the performance of the actual system compared to the expected one. Tests are designed to verify the response time, the execution time, the throughput, the resource utilization, and the traffic rate. So one needs to be clear about the specific data to be captured in order to evaluate the performance metrics. For instance, if the objective is to evaluate the response time, then one needs to capture end-to-end response time as seen by some external user, CPU time, network connection time, database access time, network connection time, and the waiting time. Then comes the scalability test. The tests are designed to verify that the system can scale up, expand up to its engineering limits. Scaling tests are conducted to ensure that the system response time remains the same or increases by a small amount as the number of users are increased. So there are three major causes of these limitations, because we have the limitation of data storage, network bandwidth, speed limit. So extrapolation is often used to predict the limit of scalability. Then we come to stress test. The idea of stress testing is to find out or to determine the behavior of software component while the offered load is in excess of its design capacity. The system is deliberately put under stress by pushing it to and beyond its specified limits. And this will ensure that the system can perform acceptably under worst case scenario or condition, under an unexpected or expected peak load. So if the limit is exceeded and the system does fail, then the recovery mechanism should be invoked. Stress tests are targeted to bring out the problem associated with certain things like memory leak, buffer allocation and memory carving. Load and stability test. These tests are designed to ensure that the system remains stable for a long period of time under full load. Here, when a large number of users are introduced in applications that run for months without restarting, a number of problems are likely to occur. The system may slow down, the system encounters functionality problems, the system crash together. So load and stability test typically involves exercising the system with virtual users and measuring the performance to verify whether the system can support the anticipated load. This kind of testing would help us to understand the ways the system will actually perform in real life situations. In reliability test, these are designed to measure the ability of the system to remain operational for a long periods of time. The reliability of a system is typically expressed in the term of MTTF, mean time to failure. The average of all the time intervals between successive failure is called the MTTF. Let me tell you again. The average of all the time intervals between successive failures is called the mean time to failure. After a failure is observed, the developers analyze and fix the defects, which consume some time. So let us call this interval the repair time. So the average time of repair times is known as the mean time to repair. Okay. Now we can calculate the value, we call it as mean time between failure, and this is equal to MTTF plus MTTR. Mean time between failure is equal to mean time to repair plus mean time to failure, MTTF. So this is the reliability which is expressed in MTTF. Please understand, this is reliability. Then comes the regression test. In this category, new tests are not designed. Instead, test cases are selected from the existing pool and executed. The main idea in regression testing is to check that no defect has been introduced into the unchanged system of a system due to changes made elsewhere in the system. And during system testing, many defects are revealed and the code is modified to fix those data or those defects. Regression test, one of the 4 different scenarios can occur for fixing each. The reported defect is fixed. The reported defect could not be fixed in spite of making an effort. The reported defect has been fixed, but something that used to work before has been failing. And the reported defect could not be fixed in spite of the effort, and something that used to work before has been failing. So one possibility is to re-execute every test case from version previous to version n before testing anything new. A full test of a system may be prohibitively expensive, very expensive. So a subset of test cases is carefully selected from the existing test suite to maximize the likelihood of uncovering new defects, reduce the cost of testing. Then comes the documentation test. The documentation testing means verifying the technical accuracy and readability of user manuals, the tutorials, and online help. The documentation testing is performed at 3 levels: read test, hand-on test, and functional test. Read test: in this test, a documentation is reviewed for clarity, organization, the flow, and accuracy without executing the documented instruction of the system. Hands-on test exercise the online help and verify the error messages to evaluate the accuracy and usefulness. Then the functional test. Follow the instructions embodied in the documentation to verify that the system works as it has been documented. Regulatory test. In this category, the final system is shipped to the regulatory bodies in those countries where the product is expected to be marketed. The idea is to obtain the compliance marks on the product from various countries. Most of these regulatory bodies, they issue safety and EMI/EMC, that is electromagnetic capability and electromagnetic interference compliance certificates, emission and immunity. So the regulatory agencies are interested in identifying flaws in software that have potential safety consequences, and these safety requirements are primarily based on their own published standards. Then comes the software safety. A hazard is a state of a system or a physical situation which, when combined with certain environmental condition, could lead to a catastrophe, accident, or a mishap. So an accident or a mishap is an unintended event or a series of event that may cause death, injury, illness, damage, or loss of property or harm to the environment. Software safety is defined in terms of hazards. A software in isolation cannot do physical damage, but a software in the context of the system and an embedding environment could be vulnerable. For example, a software module in a database application is not hazardous by itself, but when it is embedded in a missile navigation system, it could be hazardous. If a missile takes a U-turn because of software error in the navigation system and it destroys the submarine that launched it, then it is not a safe software. Safety assurance. There are 2 basic tasks performed by the safety assurance engineering team: providing methods for identifying, tracking, and evaluating and eliminating hazards associated with the system, and ensuring that the safety in the embedded it is embedded in the design and implementation is timely and cost-effective manner, such that the risk created by the user operator error is minimized. So this was about the test or testing strategies. Thank you so much. Take care.